Today we have on the bench a very small little preamp. It costs pennies. In fact, you couldn't make it for the price that you can buy it for. I won't list any particular seller because there are many, and some offer with post free but charge more, but it's about 3 or 4 New Zealand dollars. Now, the idea of this preamp was, for those of you that have watched my building of the power amplifiers, I needed just a little bit more gain. And again, I've also reviewed a couple of other preamps which are, in my opinion, way over the top. This particular preamp uses quite an old chip, namely the NE5532, which is a dual channel stereo preamp. So we have it on the bench at the moment, and I'm going to do some tests and you will be able to see what it does. Incidentally, it uses a single-ended power supply, and it will work reputedly from 9 volts to 35, which again all sort of makes common sense. The only thing is, about the lower voltages, its input overload will be somewhat reduced. Set up on the bench, I'm using a DC power supply with this battery and a variable switch mode here to adjust the voltage. At the moment I'm running it on 20 volts, which seems like a good sensible figure to start off with, and it draws round about 10 to 11 milliamps, so virtually any power supply will run this. And being single-ended, you don't have to worry about the plus or minus voltages that you would need on some preamps. Now this particular chip can run, although not in this circuit, on a plus or minus supply, but the chip itself doesn't mind. The only difference is, of course, to set the halfway point you would have to have capacitors on the output, and best on the input as well, which this in fact does have. These large capacitors are across the supply, and incidentally those capacitors are rated at 35 volts, so that would indicate the maximum that you can use with this, but you shouldn't really need anything near that. All you will gain by the higher voltage is more, or I should say less, susceptibility to overload. Now, the first thing I've noticed on this preamp, to my amazement, is the frequency response is not flat. I've checked off camera the input from the generator, and that's as flat as measurably possible. Now if you look at this is a low frequency, and you'll see, look at the graticule here and visualize how big that is, and you'll see as the frequency goes up, it's now, the HF is dropping off. We are quite a bit down now. I'll leave the time base where it is because you don't really need to look at the waveform, but you can see it's gone from here to here, and we're now at 11 kilohertz. Its low frequency response is flat as a pancake from 4 or 5 hertz, but when you get to about 5 or 6k, it starts to roll off, and it's now quite dramatically rolled off. And we were at 17, 18 kilohertz, and it sort of stabilizes there and goes back. You can see now how much higher the level is, and there's no EQ on there, and this preamp shouldn't have any EQ, and there's no evidence that it has any EQ. Now initially I thought there may have been a fault on here, but I've actually got 2 or 3 of these little modules, and they're all absolutely identical. As you can see around the chip, you've got those small capacitors which are basically RF stability, and they're not going to influence the frequency response at all. Now there are no other capacitors in the signal path except these electrolytics on the input and the electrolytics here on the output. But if the electrolytic was too low a value, that would make the base roll off, and there's nothing wrong with the base whatsoever. So why it rolls off, I just don't know at this stage. Now, it has a relatively low gain as factory default, and it has a gain of about 5. Now you can increase the gain by changing resistor 5 and resistor 6 to 100k, and that will give you a gain of approximately 10. Now, if it's a gain issue, that will make the frequency response worse. But I know this chip very well. I mean, it's just flat up to hundreds of kilohertz naturally. So I've got to investigate why this is rolling off like this, because I just don't know at this stage. Looking at the components, because like all Chinese stuff, there's no circuitry to hand. I could reverse engineer it, but can I be bothered? Probably not. But I will have a look and see if there's anything obviously wrong with the design, because this chip is basically, providing you give it the correct DC conditions, which I shall check in a moment, there isn't really much can go wrong, providing you bias it correctly. Incorrect biasing won't really make the frequency response change. It'll make it clip badly at one side or something like that. Well, anyway, let's just do a couple of other tests and see how it looks in other respects. Here we're looking at the maximum output. Now all these voltages initially are going to be with 20 volts DC applied, and that is actually giving an output of 6.4 volts. And to get that 6.4 volts, you need, let's just have a quick look, we'll measure it. You need about 1 volt going in, so that's really a gain of 6, isn't it, not 5. And you can see, if I increase the level slightly, there's clipping, and it's a little bit predominant. If I make it clip badly, it's predominantly clipping at the bottom. But an interesting thing, that is as near symmetrical clipping as you can get. If you lower the voltage, it clips from the bottom, and if you increase the voltage, it clips at the top. How weird is that? So let me do this. I've got 20 volts on it at the moment. Let's reduce the voltage. There, you can see we're now on 17 volts, and obviously the clipping level in general drops because the headroom is gone. But if I reduce the gain now, you can see it's no longer symmetrically clipping, and it's clipping predominantly at the bottom. And if I continue to lower the voltage to, let's say, 12 volts, you can see it clips dramatically. But if we reduce the gain, it's clipping quite predominantly at the bottom. If you have an amplifier with a nominal line input, 100 millivolts, let's say, won't drive the amplifier to full power. But with this preamp on there, if you inject 100 millivolts, you will get 600 millivolts out. So ideally, if you were going to use this with say the power amplifier that I've been building, you would need about 200 millivolts in to get about 800 millivolts out, if my maths are correct. But the problem is the amplifier, which you've probably seen me building and testing, is so good, using this preamplifier will mess it up, because it has roll off on the HF, and to me it's completely non-hi-fi. If you have something that isn't very important, this preamplifier will be fine. Its gain is adequate, and you can increase the gain by changing a couple of resistors, but you'll still have that failing HF response. Well, it's 2 days later now, and never one to be giving up too readily. I think I've found the problem, and this is it. Now, as per usual, of course, there's no circuit diagrams available, but so I've reverse engineered the circuitry, and this is, well, a very small part of the circuitry, and it just shows one channel, and it only shows the components that are relevant for this comment. If you see here, I'm in my own shadow here, I know, there is a capacitor across this 47K, and this is largely feedback and part of the gain setting circuitry. But here is the problem. I couldn't see why you'd have such a large value capacitor across that resistor, and it's actually a 330 picofarad. Now, for stability you shouldn't need anywhere near that sort of value, and I think they've put the wrong component on the board. At the moment I've just clipped off the capacitor, and it's completely stable, and I don't even think it needs it, but I think it should be, if it does in fact need a capacitor, 33 picofarad, not 330. Now, the reason I think they've made a mistake is because across the main supply they've got a high value electrolytic, which is what you'd expect, and they've also got a 330 picofarad to aid high frequency stability. So I think they've just misplaced it and thought 33, that looks like 330, so we'll throw them in. So I've taken that out, and this is now what it looks like. Just before I show you the frequency response, this is the 10 kilohertz square wave. I've locked it because it was dancing about a bit. I've got unscreened cables and whatever. So to make it easier, I've just frozen the scope and captured one frame effectively. So this is 10 kilohertz, and as you can see, a very, very nice square wave. Well, if you remember before, as I was really annoyed, it was rolling off like a brick above about 5K. So here we are starting, let me smooth the time base, starting at 20 hertz, and that's the area we want to look at. So there's basically 4 squares. As I alter the time base, we're up to 5K. Now this is where it started rolling off before, and I won't bore you with going all the way. This particular trace stops at 19K, but you can see it's now 10K and completely flat as a pancake. Now off screen I've done a complete sweep, and it's flatter than flat from as low as I can go, which is 10 cycles. It's just 0 dB at 10 cycles, and we're now up to 17K, as you can see, and completely flat, and before it starts to recycle again any second. But it's completely flat all the way up to 80 kilohertz. Now the thing is, this is what it should be, because as I've said to you on the previous part of the video, this chip is basically a directly coupled chip, and the limiting factor low frequency wise is the input and output capacitors, which in this case are 47 microfarad. Now they are electrolytic, and I suppose in an ideal world you would use Milo or something along those lines, electrolytics being generally frowned upon in audio paths, but I've modified one of them, and it doesn't measure any better, and I certainly can't hear any better. But if you want to be accurate, I suppose you could put a different capacitor in there. So basically all my problems with it before have gone away. I've also mentioned before that on this scope the lowest distortion you can really measure is about 0.5%, and it's mainly because the scope is low cost, because I'm poor. But there are no artifacts on it at all. I mean, you just cannot see any distortion. So all I can say is, thing is, this chip has inherently a very low distortion. If you care to look up the manufacturer's rating. So providing you give it the right volts and you don't ask silly gains from it, you will get low distortion, and there's nothing in the circuitry to make it distorted. So for the price of, what is it, $4, I would recommend this. For those of you that have bought this product, the components you need to remove is C11 and C12. Just to remember, it's the one that's right in the middle of the chip. And I haven't experimented with 33 picofarad or anything, I've just removed them completely. This is another board, I haven't done this one as yet. But those capacitors you need to leave, because they are actually across the supply and I would suggest are required. But these are the ones that are in the feedback loop, which you don't require unless you do want to limit the frequency response. But 330 picofarad is too high. Incidentally, in case you don't know, they're actually labelled 331, which is in fact 330 picofarad.